In this lesson, we will do a linear programming, or LP formulation. Step 1 is to define the variables. Variables are what you're trying to determine, and they can be given any name, variable A, variable B. Let's use variable X. Let's call X equals, okay, what are we trying to determine? Well, one thing we're trying to determine is the number of units of A to produce. And another variable, let's call it Y, is equal to the number of units of B to produce. So that's what we're trying to determine in this case study. The second step is the objective function. The function means equation. So what is the objective in this case study? It's to maximize profits. So let's call Z the variable for profit. Now we have to define profit. Well, profit will be the number of units of X that we produce plus the number of units of B that we produce, assuming we sell all our units. Now we must multiply by this profit that we make with each unit of A, and go down to the accounting department as it's given in the case. The accounting department would tell you it's 6 per unit of X and 5 per unit of Y. So that's our objective function. We're trying to maximize profit. And profit's defined by the number of units we produce multiplied by the profits that we make for each unit. So we have the variables, what we're trying to determine in this case study. We have the objective function, and if you remember, it's a linear programming problem because we're trying to make the best decision given limited resources. So step 3 is to specify the constraints or limited resources. Now to specify them, I find it easier to draw a table of 4 columns, 3 rows, and this side will be the constraints, the limited resources, R1 and R2. And here is what we have available: 5 of R1 and 12 of R2. Now these will be used up making products A and product B. Now how will they be used up? Once again, you'd go to the production department and ask, and this information is given in the case study. To make 1 unit of A requires 1 unit of R1 and 3 units of R2. And to make B, also 1 unit of R1 and 2 units of R2. After this table, we can specify the constraints. And to do this, if you recall, X is the number of units of A we produce, so let's put X there. So, and Y is the number of units of B we produce, so let's put Y there. Now we can specify the constraints. Every time, constraints for R1 is 1x plus 1y should be less than or equal to 5. And the second constraint is using up R2 in making A, and using up R2 in making B. And that should also be less than or equal to 12. So those are our constraints. So now we have basically formulated the linear programming problem. This is what we're trying to determine. This is our objective, what we're trying to achieve, which is in business is often always maximize profit, and given limited resources, given our constraints. So that's a clear picture or formulation of our LP problem. And the last step is the non-negativity. Means we don't want our variables to be less than 0. After formulating this problem, the next video we will transfer this formulation into Excel and solve it with Excel Solver.